So just to recap, like I said, remember, I'm going to go over the reasons we've learned, just to recap some of the reasons that we've learned. And I'm actually just going to start on this space here. The very first reason that we learned together, now again, like Yolanda said, some of you have done this at school, so you know more than just the reasons that we've already done. That's fine, but we are going to use what we know in this course, and then we will build on that together. So the first reason that we looked at was angles around the point. And we know that if we've got angles around a central point, they must all add up to 360 degrees. That was the first reason we learned. The second reason that we learned on Wednesday was angles on a straight line. Straight line. And angles on a straight line, and importantly, adjacent angles on a straight line, must add up to 180 degrees. They are what we call supplementary. We did also have a look at a third reason, which was complementary angles. And I say to you on Wednesday, the fact that we don't use this reason a whole lot, but it is one that we can bring up. And complementary angles add up to 90 degrees. So far, those are the three geometric reasons that we've learned. And these are the ones that we want to be able to apply in all of our questions going forward. Right now, also remember that anytime in geometry that you're going to use one of these geometric sort of concepts, we have to give a reason. So here in dark green are my reasons. Remember, guys, mathematicians are quite lazy, so you are more than welcome to abbreviate and use symbols as long as it's a symbol that I'm using. You're welcome to use it as well. Angles around a point add up to 360. Our reason is angles around a point does that. Angles on a straight line adding up to 180, literally just angles on a straight line. We abbreviate straight to STR. Some of you use supplementary angles on a straight line. That's also absolutely fine. And our complementary angles, our reason is just comp angles. So far what we have, or what we know, are those three reasons. And so in this little recap that we're going to do, we're going to hopefully apply one or more of these reasons in order to answer the questions. So let's have a look at our examples. If we look at this very first example that we have here, we have got an angle of 15 degrees, an angle of X, and an angle of 75. Now, guys, the trick comes in with geometry in that you need to start looking out for certain shapes and certain pictures, I suppose, within the diagram. So the first thing that I'm noticing here in this specific diagram is the fact that I have got a straight line here at the top. Now, obviously, there's lots of straight lines in this diagram, but what I'm seeing is that this straight line is particularly useful to me because all of the angles sort of come from that central or that main straight line. What I mean by that is, if we go a step further, we can see that all of these angles have a common vertex on that straight line. And so what that means is if I add up these three angles, I have to get 180 degrees. They are adjacent angles on a straight line. Now remember, whenever you are doing your geometric answers or you're working out for geometry, you have to have two parts to your answer. You have to give a statement and you have to give a reason. And I've said this to you before, the easiest way to remember to do both is to split your page in half so that you are reminding yourself that you have to give a statement and a reason. So my statement here, basically what I'm going to do is that I'm going to say 15 degrees plus X plus 75 degrees must give me 180 degrees. And I know that's true, and this is where I give my reason, because of angles on a straight line. Again, if you're using the supplementary angles reason, that's fine. There's no problem with that. I personally don't use it, but it's not a wrong reason. It is absolutely fine. As long as you are using a reason either I have given you or your teacher has given you, your reasons are perfect. Right, now guys, once we've made our statement, we need to go and actually solve for x, because remember the instruction here would be determine the value of x. Now, importantly, it's not of 2x, it's not of x plus 15, it's not of anything else except for x. So what we need to now do is we need to solve an equation. The first thing that I'm noticing though is the fact that 15 and 75 are like terms. So if I add them together, I'm just going to make my life easier. So x plus 90 must give me 180 degrees. And remember that 90 has come from me adding 15 plus 75. 15 plus 75 is 90 degrees. Now that I've done that, I can use my inverse operation. So I can subtract 90 degrees on both sides of my equation in order to solve for x. And so I get that x is a 90-degree angle. All right, so whenever we're doing these types of questions, this is our goal. We're trying to solve for x or determine the value of x. And in order to do that, we need to use the reasons that we know in order to eventually solve for our unknown angle. All right, so based on the reasons that we know, which I'm just going to do that, based on how I've set up my work in question 1, I want you guys to try question 2 for me. I want you to put your answer as well as the reason that you used in the chat for me. Okay, so I'm going to give you a minute, try, or 2 minutes, try question 2, and in the chat, I want to see your final answer as well as your reason. Remember, guys, to set up your page exactly like I've done here, statement, reason. Every geometry question, you have to give a statement and you have to give a reason for that statement. Okay, I've said this to you before. If you don't give reasons, you can lose up to 50% of your marks just because you didn't put reasons in. So give question 2 a try. I'm going to give you 2 minutes, and like I say, I want to see your answers and your reason in the chat, please. So like I say, look at your diagram, see what information you have there that matches up to one of the reasons that we know, and then go and determine your x value. And remember, guys, because this is basically an equation, you can go and check yourself. You go and substitute, excuse me, if you go and substitute your value for x back into the diagram or back into your original equation, it should then be left equals right, or it should give you the valid geometric reason that you use. So remember that even in geometry, you can double check your answers. Liking that I'm getting some answers. Well done. I'm going to give you 1 more minute. Remember, answer and reason. If you don't give a reason, you're going to lose marks. Okay, good, grade 8. So let's have a look. So again, look at your diagram, see what information you have on your diagram that might be useful to you. The thing that I'm seeing here is, once again, I've got the central point, but if I add all the angles around that central point, I'm going to get a full circle, which means that all of my angles together must add up to 360 degrees. So that is the statement I'm going to use here. I know that B plus 94 plus 243 must give me 360 degrees. And that is all because of you guys, as you guys have wonderfully said there on the chat, our reason is angles around a point. If you just say round a point, that's fine. I say around a point usually, but angles around a point. Now, importantly, guys, it is not angles on a straight line here, because even though we have straight lines, we don't have any adjacent angles on a straight line. If, for example, this line extended, then yes, you would have angles on a straight line, but it doesn't. We don't have one continuous straight line with multiple angles, so I'm using angles around a point here. Now, again, 94 and 243 are like terms, so let's just add them together in order to make our lives a bit easier. 94 plus 243 gives us a sum of 337 degrees. And now, because I'm solving for our unknown, we're going to use inverse operations, and we are going to subtract 337 on both sides. Would help if I wrote the correct number, wouldn't it? All right. 360 minus 337 is 23 degrees. And so we have worked out the missing angle, the missing size of our angle. Okay, so guys, what I've put there in that like a rainbow colored block, those are the reasons that we know so far. Ooh, excuse me. And as I said to you in the very first lesson, what I advise you do is you have a piece of paper separate to where you're working out, and you have this as your information sheet. And every time we learn a new reason, you put that reason down on the information sheet, because what you essentially then have at the end of geometry is a cheat sheet. And you can now use that information every time that you're doing homework, so that you start to become more and more comfortable with your geometric reasons. All right, so take a screenshot of these questions and of the reasons that we've got so far. I'm not going to ask for any hands right now because this is all a recap. If you do or are feeling unsure about anything, you need to go and rewatch the videos that are all on the website or on YouTube. Okay, so take your screenshots. Again, guys, if you do have questions, please remember to put them on the chat, or you're welcome to message Yolanda or myself directly, and we will help you. Alrighty. Woo. So what we are going to learn today is our next reason, which is vertically opposite angles. All right. So this is our next reason. I'm pretty sure there's supposed to be a block around this, but we're just gonna pretend everything's fine. Like I said, our next reason, vertically opposite angles, and this is what we're going to essentially have a look at today. So vertically opposite angles, the shape that we look out for when we're using or when we're working with vertically opposite angles is a cross shape. English is a cross shape. It's where two straight lines essentially intersect with each other, forming a cross. What this vertically opposite means is basically vertically comes from a vertex, and we can see that this E here is a common vertex, or a vertex that sits on both line A, B, and C, D. And any angles opposite each other at that meeting point are equal. So if we go to the information I've given you here, and I'm just going to choose some different colors here. The first bit of information is telling me that angle AED is equal to angle CEB. So AED is this angle up here, and CEB is this angle down here. So those two angles are equal to each other because they are vertically opposite each other. They are opposite each other at that little point where the two lines cross. The next bit of information we've been given is that AEC is equal to DEB. Let's try that again. AEC is this angle on the left here, and DEB is this angle on the right. So those are equal to each other. Again, they are equal to each other because they are opposite each other at the point where the two lines cross. And so our reason that we use is vert op angles are equal. So this is the new reason that we learn, or that we are going to learn. And again, the shape that you look out for is the cross shape. If you've got two lines crossing each other forming this cross shape, you likely have vertically opposite angles. All right, so let's have a look at this first example together. Nice and easy to start off with, as we always do, but let's see what shapes we have. So the first thing that I'm seeing is that I've got these straight lines and they are forming that cross shape. So remember I said to you, one of the really important things in geometry is to look at a diagram or look at an image and start to see patterns or start to see relationships between lines. So I've got this cross shape, that's great. And because I've got this cross shape, I know that I have this common vertex in the middle. So here, this middle point is a common vertex, or the vertex where the lines cross each other. And because I have that, I know that the angles opposite each other at that vertex are equal. So angle X is opposite 110. And so very simply put, I know that X is equal to 110 degrees because of vert op angles being equal. And that's it. You've determined the value of X. There's nothing more that you need to do. You know that it's equal to the angle opposite it. And so X is 110 degrees. Okay, so really, vert-op angles not too tricky at all. What we need to look out for are those cross shapes in our diagrams. Sorry, everyone. Alrighty, so don't want to do that just yet, sorry. Let us have a look at this question over here. This is going to be our new. Currently, I just went from 1 to 3 as well. So, you know, let's have a look at question 2. I'll make it smaller just now for you to screenshot. Again, we want to give our statement and our reason. And what I need to notice here is that I've actually got 2 angles I need to find. The first angle I want to find is angle A, and the second angle I want to find is angle B. Now, you don't have to do them in alphabetical order. It's completely up to you. But let's sort of notice a few things that we see. Well, the first thing that I see is that I've got these straight lines. So angles on a straight line could potentially be useful to me. But I also notice that I have this cross shape. And whenever I see this cross shape, I automatically need to be thinking of vert-op angles. Now, because I've got 2 angles I need to find the value of here, and what we need to remember is that we need to do them separately. So what I mean by that is you'll solve for A and you'll give a reason, and you'll solve for B and you'll give a reason. We don't try to do everything all at once. We try and do, or we do them separately. You don't have to go in alphabetical order if you don't want to. You can, sometimes it's easier, but at the end of the day, we want a value for A and B. So I'm going to give you guys 2 minutes. I want you to find the value of A with a reason and the value of B with a reason. And I want both of those answers in the chat with their reasons. Please remember to give reasons, guys. Remember, so important that we remember our reasons. If we don't remember our reasons, then we're going to lose a lot of marks for silly mistakes. Now, when I say find the value of A and B, I actually want to know what number, so what or how many degrees angle A is and how many degrees angle B is. Okay, so both of your answers should have a number attached to them. We're all doing really nicely with A, well done. And guys, what I also want you to remember is that, especially when you start getting diagrams like this, where there's more than one angle you need to solve for, often there's going to be several different reasons you can use. Oh, excuse me. I didn't sleep last night, so So, for example, if you work out A first, there's potentially 2 or 3 different reasons you could get for B. Okay, so when we do it, if my reason is different to yours, please don't stress. I will tell you what the other options will be. But please don't stress if you get a different reason to your friend or your teacher. As long as you have applied the geometry correctly, that is absolutely fine. Give you 30 seconds. Please remember, guys, ask your questions on the chat. Send Yolanda or myself a message. We will help you. Right, let's have a look at this one. So those of you asking me, how do I solve for A? How do I solve for B? How do I do this? Listen up, we're going to go through it. Now, again, it doesn't matter where you start. I'm just going to start with A. It really makes no difference. Often starting with the first letter of the alphabet, so going in alphabetical order, is useful because it'll help you get to the rest of them. So if I look at A, the first thing that I notice about A is the fact that it's on a straight line with this 110 degrees. So I can make a statement that A plus 100 degrees must give me 180 degrees. And my reason for that is angles on a straight line. Now that I've made my statement, I can go and work out my value of A. I'll subtract 100 on both sides. And so what that gives me is that A is equal to 80 degrees. Now I've said this to you before, I'm going to say it again. Whenever I start to find values, I like to put it on my diagram because it might now help me get B. Okay, now for B, there's a couple options that you have. Either what you can do is you can use angles on a straight line again, with the 80 and the angle B, and you can go and work it out like that. But because we've just learned this cool new reason of vertically opposite angles, let's see if we can apply that. Right, so I know that A is 80. I can very clearly see that my lines form that cross shape with that middle vertex. And so what that means is that the angles opposite each other are equal. B and 100 are opposite each other at the point where the lines cross. So nice and easy, B is equal to 100 degrees because of vertically opposite angles. So what's quite nice about vertically opposite angles, if you've got a value already, you just say it's equal. You don't have to do any working out. You don't have to stress about anything. You just take the value and you make it equal. If you had done angles on a straight line, so you had said 80 plus B equals 180, you get exactly the same answer. And so that's why I'm saying to you, if your reason is a bit different to what your teachers is or what your friends is, it's not necessarily wrong. Okay, there's often quite a few ways to do things in geometry with different reasons. All right, so I'm just going to make it like that. Please take screenshots. If you have any questions about either of those two that we've done, please raise your hand. I've also just realized that my number 2 is on the side and I've just lost my marbles. All right, so you're screenshotting or you are raising your hand to ask me questions. Grade 8s. The lesson topic today is vertically opposite angles. Right, we will get to parallel lines and stuff, not today. First thing. Second thing, I'm sorry, I do see hands. How do we know that the angle is out of 180? The angle is not 180 unless you're using angles on a straight line. Angles on a straight line are always 180 degrees or always add up to 180 degrees. Right. In terms of the answers, guys, you have to have A equals 80 and B equals 100. What might be different is your reason. So you can't say A is equal to like 20. That's not correct. It has to be 80. Your reason might just be different. All right, Lindor, Just pop up to unmute yourself. There we go.
Hi, ma'am.
Hi.
Ma'am, can I ask if your answer is correct, but you write statement on another line, say statement and reason, and then write B equals to 100, as well as for a reason is vertical opposite to a straight line. To Alice, will you get it wrong?
No, that all sounds fine. As long as you've got your statement and your reason with it, that's fine.
Thank you, ma'am.
Alrighty. Double words in my head and now they're gone. Sabiso?
Hello, ma'am.
Hi.
Ma'am, I wanted to ask if there was maybe an angle C. The angle C will also be 80 because it's vertically opposite with angle A.
Perfect, exactly. So guys, I
Okay,
don't know if
thank you.
you all heard that, but that was a really good question. If there had been a C here, what we would be able to say is that C is equal to 80 because those angles are vertically opposite. All right, and so exactly, as we start to add more and more letters or more and more variables, we need to start thinking about all of the potential reasons. You don't give all of the reasons, but just know that any of these answers could have different reasons. Apulele?
Ma'am, can I please ask, what if you just go straight to the answer for A?
Yeah, that's fine. I'm really just showing all of the working out. If you're able to go straight to the answer, especially for something like that, that's absolutely fine. You'll write your answer and your reason, and that's it.
Thank you.
Pleasure. Munira?
Ma'am, I wanted to ask, how did you know by question 2 that A is 80 degrees?
Because remember, the angle 80 and the angle 100 are on the straight line. So if we add them together, we have to get 180 degrees. Now, if I've already got 100 of those 180 degrees, that means that A has to be 80 because 80 and 100 give me the 180.
Thank you, ma'am.
Pleasure. Right, so guys, really importantly, it's only if you have a straight line that you can use angles on a straight line. All right, you guys have been so well behaved tonight. You should be very proud of yourselves. I think a brain break is well deserved. Here's our brain break for the day. You guys know how this works. I need to work out the answer as well. But the first person to get the answer on the chat will be the one explaining it to us. So I look forward to seeing some answers. Hopefully I can get it before all of you. Okay, so give it a try, brain break. Don't know why I've called it a brain refresher, but you know, mixing it up a little bit. It is going to annoy me though, so I'm just going to change it to break. Remember the brain break, you are looking at the information I've given you here, and I want to know the value of that very last equation. Answers only on the chat, and we will see who's correct. Okay, I've just explained how it works. You're looking at the brain break. So this, where it says brain break, and you are trying to find for me the value of this last thing. So you need to work out what a caterpillar is worth, what a clock is worth, what the flower is worth to make all of these equations true and work out the value of the last one. Okay, so just be careful, just because I've only just noticed that. Make sure the answer hasn't come through yet. No. Ah, Sanyane, well done. I didn't even have time to send it to you, Linda. Well done. Okay, Sanyane, if you want to put up your hand and explain how you got 31, that is amazing. Sinyane, do you want to raise your hand for us? There we go. Right, explain it for us.
Okay, ma'am. So first I said 21 divided by 3, which gave me 7. Then I said
Perfect.
19 minus 7, which gave me 12. And then I said 12 divided by 2, which gave me 6. Then I said 15 minus 7, then I said 15 minus 7, which gave me 8. And then 8 minus 6, which gave me 2.
Good.
Then I said 7 plus 4, since it's 2 flowers, times 6, which gave me 31.
Okay. And you know what I've just noticed here, guys? Is all of these little caterpillars have a flower on their head, and this little caterpillar does not have a flower. So based on what,
Oh.
yeah, I've also just noticed it, Sinyane, so don't even stress. So based on what Sinyane has told us, we know that the caterpillar with the flower is 7, and we know a flower is 2. So a caterpillar without a flower would be 5. 2 flowers we know is 4, and this is 6. And so it gives us, Sinyane, do you want to tell us?
29. 29.
Excellent. Well done.
Well done, Sinyane.
This is why it's so
Yeah.
important to look at questions carefully. Okay, so guys, the reason the caterpillar at the bottom isn't 7 is because it doesn't have a flower on its head. Now, because the flowers are 2 and the caterpillar with a flower is 7, 7 minus 2 gives us 5. And so our answer is 29. So I apologize if anyone got 29 before, Sinyane. I don't read the questions properly. I don't see any 29s before that, so that's fine. But this important lesson, read your questions carefully. Don't make silly mistakes like we just did. All right, sweet children, let us have a look at some more geometry. Right, so I'm going, it's so helpful if my brain wanted to work every now and then. So I think this is now question 3 that we're on, because I apparently just forgot my own notes and decided to add a random question too. So this is question 3 that we're having a look at. All right, so we'll do this one together because we'll step up. Again, we've got a statement and a reason. And what we see here is, once again, we've got this cross shape. Okay, so whenever I see this cross shape, I need to start thinking about vertically opposite angles, especially when I'm given the angles opposite each other. Because now I can make the statement that 3x is equal to 45 degrees because vert-op angles are equal. And now remember, guys, you're solving for x. So what I now want to do is divide both sides by 3 to get x alone. And so what that means is that my value of x here is 15 degrees. So it doesn't matter that I'm starting to add coefficients or that I'm starting to add more information to my question. It doesn't change how I deal with it. The vertically opposite angles are still equal to each other. I just need to remember to set up my equations properly. So importantly, guys, 3x is 45. X alone, remember you're solving or you're determining the value for x. X alone is 15. Right, guys, you need to be listening. I've just explained how we got 15. So you're not paying attention, it's just creating more disruption. I got 15 because remember 3x is 45. I don't want 3x, I want x. So using inverse operations, I divided both sides by 3. That leaves me with just the x, and 45 divided by 3 is 15. If we now go sub that in, that would be 3 times 15 degrees, and 3 times 15 is 45. 45 is equal to 45. They are vertically opposite, so they are equal. Okay, there's another question here that no, we can't say they intersect each other because even though the lines are intersecting with each other, that isn't a geometric reason. We do need to specifically say vert-op angles equal. All right, Take your screenshot of this one, and then I'm going to move over. Satenda, I haven't asked for questions, but what is the issue?
Ma'am, I wanted to ask, ma'am, how come did you not say 3x plus 45 degrees equals to 180 degrees?
Because they're not angles on a straight line.
Okay, ma'am.
We only use equals 180 when they're on a straight line. In this case, we can clearly see that they are opposite each other. And when they're opposite each other, they are equal to each other.
Okay, ma'am.
All right. So I want you to try question, what are we now on? 4. My numbering system's gone out of whack. I want you to try question 4. Okay, so by yourselves, give this one a go. Look at your diagram, see what information you have, see how that's potentially useful to answer the question of determine the value of X. Remember, you have to give a statement as well as a reason for that statement. And remember, the instruction is determine the value of X. Guys, remember, just because there's an X in both angles, it's the same X. So once you've worked out X once, you've got X. I'm not asking for 2X, I'm asking for X and X only. So give it a try. We'll have a look in 2 minutes. Remember your reasons. Remember your inverse operations when you're starting to solve an equation. Remember, I said to you before as well, solving equations becomes a very, very important part of maths. So you need to be able to solve equations. We have done solving equations. So if you're not 100% sure, go and find those videos and rewatch them. But then carefully think about your inverse operations. And we're going to have a look in a minute or so. Quite a mixed bag of answers. Again, grade 8s, once you've got X, you've got X. There shouldn't be 2 values for X. X is X. If you sub it back in, you'll get different values for your actual angles, but X is X, that's it. Right, let's have a look. So, first thing that we see, once again, is we've got this cross shape, right? The lines are crossing with each other. We've got that common or that intersecting vertex, which means that 2x minus 40 plus x plus 30, 2x minus 40 must be equal to x plus 30. And so that's the statement I can make. 2x minus 40 degrees is equal to x plus 30. Why? Because angles vertically opposite each other are equal. Right, so again, if we go back up to our diagram, they are directly opposite each other at the point where the lines cross. They are vertically opposite. Now remember the question said, determine the value of x. So I'm going to solve for x. Now this is an equation where we've got x on both sides, so we need to use our inverse operations. This x I'm going to make join the 2x on the left. So 2x inverse operation minus x is equal to, and this negative 40 must now come join the 30. So 30, again, inverse operations plus 40. 2x minus x are like terms. 2x minus x is just x, and 30 plus 40 is 70. So once you've got x, you're done. You can sub it back in, and you could say 2 times 70 minus 40, which gives you 100 degrees. And you can say 70 plus 30, which gives you 100 degrees. And it proves the point that the angles vertically opposite each other are equal. They're both 100 degrees when we sub it in. And so we have correctly worked out our value of x. Now, again, grade 8s, if you're struggling with the solving of equations, you need to go and watch the videos, right? This is not a solving equations course. We have done that. You need to go watch the videos. What I'm more concerned about here is that you are correctly applying your geometry reasons. You're not dumb. Silly mistakes happen. Just make sure you're correcting your work as you go along. So I'm going to wait here for you to take screenshots. If anyone has any questions, now is the time to raise your hand. Otherwise, we'll have a look at one more.
Sorry.
No?
I just saw Little by observation on the video. So Little, you must find a reaction button where you can click on it and it can allow you to raise your hand. So don't use your physical hand. Okay, sorry.
You've got the reaction. No, I see he's got it up there. Okay, so what's your question? Oh, your audio. Ah, there we go.
I wanted to ask why we're subtracting the 2x minus x.
Okay, so remember, it's all because of inverse operations. If we look at the equation, x is on the right, I want to bring it over to the left. In order to do that, I have to do the inverse. It was plus x, the opposite is now minus x. So I always have to use inverse operations. The same goes with the 40. So it was minus 40. When I bring it over, it became plus 40.
Okay, ma'am.
Good. Seppo?
Ma'am, so here what I did was, the only mistake that I did was just not to start by solving for x, by moving the like terms to the one side, and then I start with the numbers.
Okay, but do you
And then-
understand why we do what we do?
Yes.
Good. Okay, and then?
And then what I got was x plus 2x is equals to 40. No, this is the correct one. The wrong one was just x plus 40 plus 2 plus 30, which gave me 90, which I said it is equals to 90 because it must be 90 degrees. But the only wrong thing was I did x is equals to 19 minus 17. And that gave me an answer of 20.
Okay, Seppo, I'm going to be honest, you cut out quite a bit there. As long as you understand why we need to do it like this, it's okay if you made a mistake, just make sure you've done your corrections.
Yes, ma'am.
Okay. So guys, just remember, like sometimes like silly mistakes happen, like we forget to do the inverse or whatever, and these lessons are the place to do the silly mistakes, right? Because it doesn't matter here, but it's not like this is for marks or anything like that. This is where you learn. So as long as, like I've just said, you've made the mistake, but you've corrected yourself, I don't mind.